Greetings. This week we're focusing on 8th grade statistics and probability. Standards include investigate patterns of association and bivariate data, including scatter plots and two-way tables. John records the number of days of vacation a family takes and the amount of money the family uses for souvenirs. He creates the scatter plot below. Identify any patterns in the data. There does not appear to be any pattern in our data. Therefore, we cannot make a statement about the relationship between the vacation and the amount of money a family uses for souvenirs. Try not to force some kind of pattern in the data. It is okay for bivariate data to not form a particular pattern. Alan plants some trees outside his home. He records the height of the tree and the amount of sunlight available through a window. Identify any patterns in the data. The overall general pattern between the variables seems to be a negative linear pattern. We can say as the height of the trees are increasing, the amount of sunlight is decreasing. Further, there appears to be an outlier in the data. Dr. Anderson records a healing index for his patients who have broken an arm over time. Identify any patterns in this data. There appears to be a positive linear pattern to this data. So we could say that as time is increasing, the healing index is also increasing. Dr. Donald is conducting an experiment on headache pain. She gives respondents with a headache a pain medication and records their pain levels over time. Identify any patterns in this data. There appears to be some kind of pattern between the variables, however, it is not linear. We could say that there appears to be a nonlinear pattern between time and headache pain level. Further, even though 8th grade students may not know the specific type of nonlinear relationship that exists between the variables, we know that this is an exponential decay relationship of some kind that they will experience in Algebra 1 material. Maestro Gunther is a circus manager who is training some horses to participate in the next show. He assesses their ability near the beginning of training and at the end of training. Identify any patterns in this data. The data appears to be in two sets of clusters. It would be hard to make a particular statement about the relationship between time and ability. Try not to be tricked into thinking this is a positive relationship. Because the data is clustered in such a way, we don't know any particulars about the middle time frame and cannot make up a relationship outside of the data which we know. Ashley wonders about the amount of rain her corn plants get and their weekly growth. She creates a scatter plot. Draw the line of best fit and determine its equation. We try to aim to draw a line where half of our points are above the line of best fit and half of our points are below the line of best fit. Here's one possible solution. I see that the line in which I drew has a y-intercept of 0, 2, and it also has a positive slope of 1/3. We rise 1 and run 3. The equation of the line of best fit is y equals 1/3 x plus 2 when we use the equation y equals mx plus b. Answers can vary since we are informally finding the line of best fit for now. Paige wonders about the time after bug spray is applied and the number of mosquito bites that occur. She creates a scatter plot. Draw the line of best fit and determine its equation. Notice again that half of our points are above and half are below our line of best fit. I can see that this is a negative slope of about -2/3, where we start about here and we go down about 2 and over about 3, with a y-intercept of approximately 17. Our equation then is y equals -2/3 x plus 17. If we knew specific points, we could find the equation of the line given 2 points. However, since we do not know exact data points that our chosen line goes through, we are forced to make an estimated guess on the line of best fit. Ms. Romero wants to explore the relationship between the amount of time her students spend playing video games and their grades on the previous unit test. She creates a scatter plot for the data. Identify which pairs of points would be appropriate to use to find the line of best fit for the scatter plot. So I've kind of drew a line here as an estimation. If I go through the points listed, I would have the point 4 and 95, which is well above our chosen line, our line should be, so A can't be it. We could choose 185, which would be here. However, that's well below the line, so we can exclude then B and C. We could choose 1 and 100, which seems slightly above our list, as well as 5 and 80. That seems a little steep. What about 1.5, 95, and 7, 70 seems to fit just perfect for us. So we will use the points 1.5, 95, and 770. So we first need to find our slope. Our slope is the change in y over the change in x, which simplifies to -4.5. We can see that our y-intercept is at 100. Therefore, our equation is y equals -4.5x plus 100. Two-way tables. Mr. Aziz has asked Jack to organize the results of the class survey on the type of fundraiser they should have to raise money for their science club trip. How should Jack organize his data? The following data was collected. 2 students chose burgers, 9 chose pizza, and 9 chose subs, for a total of 20 students. But what if we wanted to include the grade of each student too? The table we constructed here is for categorical data with only one variable. Let's construct a table for categorical data having 2 variables, grade level and the type of food. So given the information we have, we can put the grade level along the left-hand side and burgers, pizzas, and subs along the top and start tallying all of them together. Now that we know this information, what if this were a grade competition? What kind of food will we use for our fundraiser? So when I look at the 6th grade, we would either want to choose pizza or subs. 7th grade, we would want to choose pizza. And 8th grade, we would want to choose subs based on the data that we have. We can see patterns of association in bivariate data by displaying the frequencies and relative frequencies in our two-way table. Let's help Ashley organize her data into a two-way table. Use the two-way table to suggest a paint color for her room. Our options are blue and yellow, and our room choices are the bedroom and the kitchen. I first want to tackle how many are blue and bedroom. So I can see that there are 1, 2, 3, 4 options which choose bedroom and blue. When I look at the bedroom and yellow options, I see that there are 6 choices. Kitchen and blue are 1, 2, 3, 4, 5. Kitchen and yellow are 1, 2, 3. The remaining. Then we can create our totals. Adding across, we have a total of 10 and 8 for bedroom and kitchen respectively. The totals for our blues and yellows are 9, and then altogether we have 18. When I look at the data, I see that her bedroom should be painted yellow and her kitchen should be painted blue, because that is where most of the data lies. You wonder if people eat breakfast and whether or not they have energy at the end of the day. Organize your data into a two-way table. Take a moment to pause the video and fill in the table provided, given the data provided. We should have 10 that select breakfast yes and they have energy yes. So we should have 10 that are yes yeses. We should also have 3 that are yes they ate breakfast and no they have no energy. Further, we should see that there are 2 that had no breakfast and still had energy, and that there were 9 who had no breakfast and no energy. Creating our totals, across we get 13, 11, and down below we have 12 and 12, for a total of 24, no matter if we add the columns or we add the rows. We now can grab some information from the table. Of the people surveyed, what percent eats breakfast? So of the total people that we have will be our denominator. There were 13 which ate breakfast, for a total of 54.2%. Of the people surveyed, what percent doesn't have energy at the end of the day? So of the total people of 24, there were 12 that had no energy. So 12 divided by 24 is 50%. Of those who eat breakfast, what percent doesn't have energy at the end of the day? So of all of the people who ate breakfast, 13, there were 3 that had no energy at the end of the day. So 3 out of 13 is 23%. Of those who have energy at the end of the day, what percent eat breakfast? So of those that have energy at the end of the day, which are 12, 10 of those ate breakfast. So 10 divided by 12 is 83%. Can we make any conclusions based on our table? We can say that those who eat breakfast have energy at the end of the day, and those who do not eat breakfast do not have energy at the end of the day. Given the two-way table, answer the following question. What percent of people surveyed take their shower at night? So, of the total people of 50, at night, there are 23 which take their shower at nighttime, so 23 out of 50 is 46%. Of the children surveyed, what percent chose firemen as their career choice? So of all the children surveyed, 100, there were 40 out of the 100 which chose firemen as their career choice, so 40%. Of the people who prefer chocolate chip cookies, so of the 30 who prefer chocolate chip cookies, what percent are aged 11 to 20? There are 7 out of 30 who prefer chocolate chip cookies when you are aged 11 to 20, which is 23.3%. Examining frequencies in two-way tables and other displays of categorical data gives information about associations. Lucy's statement, "I don't think there is an association between age and whether or not you wear a watch." So given the table, let's first turn our table into relative frequencies to see if Lucy's statement is correct. When I look at the relative frequencies listed here, there is a significant difference between your age and whether or not you wear a watch. So Lucy did not make a correct correlation. Trevor thinks There is a possible association between age and the type of exercise a person prefers. We have biking, running, walking, and then a year range. Let's turn our table into relative frequencies. When I look at my relative frequencies, I see that there is in each category a significant difference between the age and the running. So we see that there is a preference for each type of exercise, and it does appear associated with age range. We could say that Trevor made a correct conclusion. Jerry's statement, I don't think there is an association between the type of pet people have and whether they keep their pet inside or outside. Again, we'll turn our table into relative frequencies. When I look at all of our frequencies, they are not significantly different from one another. So it is safe to say that Jerry's statement is correct, that there is no association. We can identify possible associations between categorical variables, again by looking at the relative frequencies. Identify the correct frequency table for the body of the table listed. So we have pop rock, country, rap and hip hop, drama, action, and comedy. Find the relative frequency of the body of our table here. Take a moment to pause the video and see if you get the correct answer. The correct answer is the bottom right. To obtain the relative frequency, we take each individual square and divide it by the total. So 15 out of 150 is 10%. 18 out of 150 is 12%. 19 out of 150 is 13%, etc. We can also make an identification that when looking at the relative frequencies of this table here, there does not appear to be a correlation between movies and music. So examine the two-way table. Which possible association between the type of music a person prefers and the type of movie a person prefers is the best fit? There appears to be an association, or there does not appear to be an association. The first thing we'll need to do is turn our tables into relative frequencies. And as we can see from the previous couple of slides, that there does not appear to be an association between the type of music a person prefers and the type of movie the person prefers. Take a moment, pause the video, and examine the two-way table. Which possible association between grade level and the color shirt a person prefers is the best fit? Is there an association, or does there not appear to be an association? Again, turning them into relative frequencies, we take 10 divided by 150, 8 divided by 150, 31 divided by 150, so that we can find the relative frequencies as follows. When I take a look at my relative frequencies, I see that 20, 18, and 22 appear to be higher, but not necessarily an association. But we can say that there does appear to be an association between grade level and the color shirt a person prefers. Although not significant, there is a slight association.